Have you ever wondered what an examiner is really thinking when they're marking your paper? It's not just about getting the science right. It's not using the exact words that unlock those marks. So today, that's what we're going to do. We're doing a deep dive into question 9 from an AQA GCSE Chemistry paper, and we're going to use the official mark scheme to show you precisely what gets you full credit. Let's get into it. And we're going straight to the source for this one, the official AQA mark scheme from June 2024. So this isn't us guessing. We're going to see the exact scientific points and the precise language that examiners are actually trained to look for. Honestly, this is what makes the difference between a good answer and a perfect one. Okay, so here's the plan. We're going to tackle this question bit by bit, just like you would in the real exam. We'll kick things off with a classic definition, then we'll look at dilution, move on to the practical skills of titration, absolutely nail the calculation, and then finish up with a big explanation question on reactivity. So let's get started.
First up, question 9.1. Now this is a really fundamental concept in acids and alkalis, and it's a classic 2-mark definition question. Let's see exactly what they're asking.
So the question is simple enough. What is meant by a weak acid? 2 marks up for grabs. Just take a second and think. How would you phrase your answer? What are the key bits of science, those key buzzwords you'd need to include?
And here it is, the perfect answer, straight from the mark scheme. For your first mark, you need this exact phrase, is partially ionized. See how specific that is? It's not doesn't fully react or is less strong. And the second mark, that's for the context, in aqueous solution, which, just means when it's dissolved in water. Now, here's the really important part. The mark scheme says that second point is dependent on the first. You can't get the mark for mentioning water if you haven't already said it's partially ionized. It just shows that precision is everything.
All right. Let's move on to 9.2 and see how this builds. This part is all about testing your understanding of what's happening on a particle level when you change an acid's concentration. Okay, so the question asks you to explain what happens to the pH when you dilute an acid. Now, you've got to watch out for that word explain. It's a massive clue. It tells you that just a simple statement isn't going to cut it. You need to say what happens and then, crucially, why it happens.
And here is that perfect 2-mark answer. The first mark is for just stating the fact. pH increases, right? As you add more water, the acid gets weaker, less acidic, so its pH value moves up closer to 7. The second mark, the really important explanation part, comes from this exact phrase, because the concentration of hydrogen ions decreases. That's the science behind it all. So it's 1 mark for the what and 1 mark for the why. Simple as that.
Okay, let's move out of the theory and into the lab. Question 9.3 is all about the practical procedure for a titration. And trust me, examiners absolutely love to test your knowledge on this stuff. So the setup is this. The burette is already full of acid. Your job is to list the next 3 steps you need to do before you even think about opening that tab. The question is pretty clear that you need to name the equipment you'd use as well.
Right. According to the mark scheme, the first point is absolutely mandatory. It's about how you measure out the alkali. You have to say you use a volumetric pipette. Just writing measuring cylinder won't get you the mark here, because for the kind of precision you need in a titration, the pipette is the only tool for the job.
Now for the other 2 marks, you've actually got some options. You just need to pick any 2 from this list. So you could say you put the alkali into a conical flask, or you could mention that you add an indicator. A really crucial one is to take the initial burette reading. You can't know how much acid you've used if you don't know where you started from. And finally, you could say use a white tile, which just helps you see that color change much more clearly. Any 2 of those and the marks are yours.
All right, it's time for the maths.
Now don't worry, titration calculations always follow a set pattern. If you can learn the steps, you can pretty much tackle any of them. Let's break this one down. So here's the problem. We've been given the moles of sodium hydroxide and the concentration of the hydrochloric acid. We need to figure out the volume of the acid we used, and this is super important. The answer has to be in cubic centimeters.
First things first, we need the right formula. You probably know that concentration equals moles over volume. Well, since we're trying to find the volume, we just have to rearrange that to get volume equals moles over concentration.
Now for the easy part. We just plug in the numbers they gave us. We've got 0.0045 moles and a concentration of 0.15. So our calculation is simply 0.0045 divided by 0.15. You punch that into your calculator and you get 0.030. But hang on, be really careful with the units here, Because the concentration was in moles per decimeter cubed, our answer for volume is currently in decimeters cubed. Stopping here is such a common mistake, and it'll cost you a mark.
So remember how the question specifically asked for the answer in cubic centimeters? Well, to get from decimeters cubed to centimeters cubed, all we need to do is multiply by 1,000. This unit conversion is that vital last step to get full marks.
And that gives us our final answer, 30 cubic centimeters. See? The first mark was for doing the calculation, but that second mark was for getting the unit conversion right. It's a perfect example of how paying attention to the tiny details gets you every last point.
Okay, we're on the final stretch now, the last part of the question, 9.5. This is a 3-mark explanation, which means you need to build a really solid, logical, scientific argument, linking all your points together nice and clearly.
So the question wants us to explain the difference in reactivity between two group 2 metals, calcium and magnesium. And they even give you a massive clue. They tell you that a calcium atom is larger. So why does being bigger make it more reactive?
Here is the perfect 3-step argument, straight from the examiner's handbook. First, you state that in calcium, the outer shell electrons are further from the nucleus. That's your first mark right there. Second, you explain what that means. The outer electrons are less strongly attracted to the nucleus. The mark scheme also says you could mention increased shielding here, more inner shells blocking the nucleus's pull. And finally, the logical conclusion. Because that attraction is weaker, positive ions are formed more easily. See how each point just flows into the next? That's a perfect 3-mark explanation.
So after breaking all of that down, what's the big takeaway here? Well, it's this. Precise, key scientific terms are what score the marks. It's not about writing pages and pages, it's about writing the right things. Using phrases like partially ionized, concentration of hydrogen ions, and less strongly attracted, that's what separates a top-tier answer from just an average one.
And that all leads to a final, really important question for you. I mean, we've broken down one question together, but the real power comes from applying this method yourself. So how can you use this technique, this way of thinking like an examiner, on the next practice question you try? Because that's how you learn to give them exactly what they're looking for, every single time.